Hey, how's it going? Welcome to my channel. So today we're gonna do the Leetcode Decode Ways. So basically, A map to 1, B map to 2, Z map to 26, and you are given a string of numbers, and you have to output the number of ways to decode the string. So for example, 111 can be mapped to 3 A's, or it can be mapped to 1 and 11, so it is A and K respectively. And note that 06 cannot be mapped to F since 6 is different than 06. So given a non-empty string num containing only digits, return the number of ways to decode it. So for 12, there are 2 ways because you can separate them into A and B or put them together as L. For 2 to 6, there are 3 ways. You can separate them into 3 letters, BBF, or you can put this 2 together, or you can put this 26 together. For 0, it's outputting 0 because there are 0 ways to decode a 0. So basically, from here you can see that if a string contains leading zeros, it should be mapped to 0. There are 0 ways to decode that. For 1, obviously it's 1. So here I have example for 1262. So how many ways there are to decode 1262? Okay, so basically you can either start with 1 or starting with 12, right? For 1 to 62. So if you start with 1, then you have 262 left. So you either start from 2 or you start from 26, right? Okay. So if you start with 2, then you are left with 62. Right? So you either start with 6 or you start with 62. But because 62 is out of the range, out of 26, then you can only start with 6. So you start with 6 and you left with 2, and that's one way, right? And we haven't finished here, so let's see. If we start with 26, then you're left with 2. So there is a way. So this is 2-way, the second way, right? And remember, if we start with 12, we are left with 62. We can either start with 6 or we start with 62, but 62 again is out of range. So we can only start with 6 and we are only left with 2. So how many ways there are to decode 1 to 62? There are 3 ways, right? 1 pass, 2 pass, and 3 pass. So basically, you can use this and write a recursive function. And basically at this point, you can call like 1 plus the number of ways to decode 262. And at this point, you can call like 2 plus number of ways to decode 62, something along that line. And if you use like a memoization to store duplicates, then you can save a lot of memory. But today I'm going to talk about like a DP solution. The DP solution is a little bit subtle. It's harder to think, but because of the code is like much small, only a few lines. So I'll talk about the DP right now. So basically, the DP is actually initializing array, a DP array that is length of s plus 1. The reason is because like we need some buffer in the front so that it's easier for us to calculate later. I will explain you along the way. So what this DP means is that so like DPI means like for length I array, for length I, so for I length string, how many ways to decode. So basically, this number means that for length 1, for 1, how many ways to decode. This number means for 12, how many ways to decode. This number means for 1 to 6, 1 to 6, how many ways to decode. And this last number means for 1 to 62, how many ways to decode. So basically, at the end, we just to return DP minus 1, the last number for our result. So let's see. If here we know that there are only 1 element in the array and that number is 1. How many ways to decode 1, right? Let's go to here. For 12, how many ways to decode? There are 2 ways, right? You either like separate 1 and 2 and make it 1, 2, or you put 12 together, right? So there are 2 ways. So how does that 12, how does that 2 actually comes up? You can see here, right? So if you have 1, so our question is how to get 12, right? So you can either start at 1, right? And you can start at 12, right? So basically it's actually adding this 2 previous number together. And so actually this number should be initialized as 1. I'll let you know why. That's because so you will find DPI will equal to DPI minus 1 plus DPI minus 2. So this DPI minus 1 right here is what? Is how many ways to decode 1. And here it is how many ways to decode an empty string. So if you add that number together, it will give you the result. So you can see here, right? So in order to get 12, you can either start with 1. So the previous number, there's only 1 way to decode 1, right? So basically, that's why you add this number, the left part. And how many ways to decode an empty string? We don't have it in this graph, right? So that's why we initialize it at 1, so that we can, by adding these previous 2 numbers together, we can get the correct answer too. Okay, let's see. If our I is right here, we can also apply this. So basically, it will be what? It will be, let me just plug in my power outlet because it's running out of battery. Okay, cool. So basically here we are asking, how do we get 1 to 6? How many ways, right? So for 1 to 6, you can see here 1 to 6, here 1 to 6, or here 1 to 6, right? So there are 3 ways. We know there are 3 ways, but can we still apply this? Yes, we can. So what is DPI minus 1? It is 12, right? How many ways to decode 12? And what is DPI minus 2? It is minus 1, minus 2. It is how many ways to decode 1, right? So you can see that in the graph, you can see for 12, I can either go here and add 6, right? Or it was already 12 and I add 6. So I know there are 2 ways, which is this number, right? So that's why I add 2 for the left part. And I minus 2, which is 1. So I can go from 1 to 6 because I can add 26. So how many ways to decode 1? If you look at the DP, it will give you 1. So you add 1 to this number and it will give you 6. So basically, like the hard part for the DP question, the DP solution is to come up with something like this. And it is not the most intuitive one, adding the previous number and the previous, the like I minus 2. But if you see the graph, you can see how that works. So let's see, if my I is here, I can either add, like, how many ways to decode 1 to 6, and add that to how many ways I can decode 12. So let's see. 1 to 6, there are 3 ways. For 12, it's 2 ways. Oh, actually, so for 1 to 6, there are 3 ways. I add 3 to here. But I check this string. 62 is out of range. So at this, if it's out of range, I will not add I minus 2, because like there is no way to go from, because this is out of range, so it's not impossible for me to add the previous count. So again, like this part is the most not intuitive part, but once you somehow like see the pattern, and you can try to code this up. Okay, let's do the code. First of all, we initialize DP array as 0 to the length of s plus 1. Again, the reason why we initialize it one more is because we have to deal with something like empty array, and if we don't have some buffer on the left, it's hard for us to go like to to calculate the I minus 1 and I minus 2. So remember, our DP0 has to be 1, because like once you find that when your I is at here, it has to be 2, then you know the 0 should be initialized as 1. Okay, so let's see. So right now the DP array is looking like this. If this number is from 1 to 9, this number can be 1, right? Because there are one way to decode one letter, right? But if your number is a leading 0, remember this case. Note that 0, 6 cannot be mapped to F, since 6 is different than 0, 6. So basically it means that if there's any leading zeros, the whole array will output 0, because there are no way to decode a leading 0, a number starting with leading 0. So what I will do is that I will check if DP, I will check like if S I minus 1 is equal to 0, then my DPI will become 0. Else, so basically it's 1 to 9, then my DP1 will become 1. So I'm saying S minus 1 here because, oh, actually I'm trying to say if DPS0 is, so basically if my first letter is a leading 0, then there are no ways to decode. If my first letter is a non-zero letter, then there is one way. Okay, right now our array will be like this. So what I would do is that for I in range, so basically I'm done with a DP1, right? So I will do range 2 to length of S plus 1. So you can see that index here, I'll write the index here as 0, 1, 2, 3, 4. Yeah, these are the index for the DP